we're going to learn some special proportion theorems that apply to triangles. These are called the Triangle Proportionality Theorems. So the first one, it says if a line parallel to one side of a triangle intersects the other two sides, then it divides the sides proportionally. That's going to be our buzzword for today, proportionally. Everything in this lesson is proportional. So you're just going to write proportions. So what I'm saying here is if these two lines are parallel, see the little arrow means they're parallel, that if this side is, say, this is 6 and this is 2, then over here, if this one's 8, this one's 4. No, it's not. We'll make this one 9. This would be 3. So proportionally means 6 to 2 is 3, and then 9 to 3 is also 3. And we would just write a proportion to solve those. You have to be careful, and I'll show you some examples. If I ask you about TU and QS, that's a little bit of a different proportion. But for now, it's just that easy. 2 to 3, 6 to 9. The converse says, if a line divides the sides of a triangle proportionally, then it's parallel to the third side. So if I gave you numbers and they were in proportion, you would say, hey, TU is parallel to QS because the sides were proportional. The next one kind of extends that to if I have 3 parallel lines. You can see the little arrows there. 3 parallel lines intersecting 2 transversals. Remember, the transversal is a line that crosses 2 other lines. So T and M would be my transversals. Then they divide the transversals, you guessed it, proportionally. And we'll see some examples. So maybe this is 2 and this is 3, and this one's, I'll just use 6 again. So if we're looking at proportions, you could say 2 over 3 equals 6 over what? Or you could say 2 over 6 equals 3 over what? And we would end up with 9. So these little pieces are in proportion. This one, the angle bisector. If a ray bisects an angle, so there's going to be a notation that this angle was cut in half. Then it divides the opposite side into segments whose lengths are proportional to the other 2 sides. And this one may be the most challenging of the 4 theorems. So we're saying this is an angle bisector. So CA to AD. So this piece to the side next to it equals CB to DB. So this over here might be divided in the ratio 2 to 3. So CA and CB would also have that same ratio of 2 to 3. So you could look at it 2 ways. You can say 6 to 9 equals 2 to 3, or you could go this way and say 6 to 2 equals 9 to 3. But they are proportional. All right, let's do some practice with those and see what that's actually going to look like in a question. Use the given information to determine whether DE is parallel to BC. So remember we said if these lines are parallel, then these pieces on each side are going to be in proportion. So I'm going to go ahead and write a proportion. There's a couple of different ways you can write your proportion. I kind of like to write it the way it appears in the picture. I'm going to write 6 over 9 and 4 over 6. Okay? 6, 9, 4, 6. And see if those are in proportion. There's a couple of ways we can do that. We can simplify both fractions and see if they simplify to the same thing. Or we could multiply. We could do our cross products. 6 times 6 is 36. 4 times 9 is also 36. So they are proportional. If you reduce the fractions, you'll find out that it's 2/3 equals 2/3. and that works too. So are the lines parallel? Yes, the lines are parallel because those sides were in proportion. The only proportion you can't write from this picture is you can't put 4 over 9 and 6 over 6. You can write your proportion this way, or you could go from side to side. All right, let's look at number 2. This is that angle bisector. See the markings in the angle bisector. So that means that these two sides are in proportion with these two parts of the third side. So I'm just going to go ahead and write 12 over 8 equals 9 over x. And some of you are going, well, what if I wanted to write 12 over 9? Go right ahead. If you do 12 over 9, you're going left to right, then you put 8 over x, and we will end up with the same answer. So there's different ways to write your proportion. I'm going to go ahead and do my cross products. If you want to reduce this first, you can, if you recognize 12 over 8. Otherwise, I'm just going to write 12 over x equals 72. X is 6. And you can always plug that back in and double check it. Next, find the length of AB. So here I'll put an X here. Notice these are parallel. There's this little arrow. So that means these pieces are in proportion to each other. So you have your choices on how you want to write your proportion. I'm just going to put x over 12 equals 5 over 6. X over 12, 5 over 6. And then a lot of you are going to notice, hey, 6 times 2 is 12. I bet x is 10. It is. And if we had done cross products, we would get 60 equals 6x. And of course, x is 10. So that works. Same thing for number 4. I think we need to know that these are parallel to each other, and then we can solve for x. So I'm going to write x over 25, just because that's what it looks like to me. And then I'm going to make this one match, 8 over 20. So if I multiply here, I'm going to get 20x equals, 8 times 25 should be 200. So x should be 10. And you can double check your proportions if you want to. If you said, okay, let me see if that's really right. Is 10 over 25 equal to 8 over 20? Yes, it is. So you can double check. Now, this is one I want to warn you about. Notice we have our parallel sides, and we have pieces over here. But this time they're not asking us for the other side that's divided proportionally. They're asking us for those bottom pieces. So be really careful. You should be able to look at this picture and notice, hey, there's a little triangle, and then there's a medium triangle, and of course we have the giant, big triangle. So let's make sure when we set up our proportion, we're comparing the same type of side to each other. So if I compare the 4 to the 3, that's the bottom side and the right. I could say 4 to 3. I'm not going to say 6 to x, because 6 doesn't represent the same thing the 4 did. 4 was part of this side of the triangle, and then 3 was that one. So when I want to do this side of the triangle, it's actually 10 to x. So when the bottom piece, that parallel line, is involved, you have to take that entire side. And we can multiply this out and get 30 equals 4x. And I believe 30 divided by 4 is 7.5. So x is 7.5. Be ready for some decimals or fractions on some of these problems, because they just work out that way. Now when I'm solving for y, I'm going to go back to the 4 over 3, just in case I made a mistake finding x. I didn't, but just in case. I'm going to go back to the original, 4 over 3. Now the blue triangle, this entire side, is 15 over y. So you can't say 4 over 3 equals 5 over y, because that's not the same comparison. You have to use the whole side of the triangle. So now when I multiply those, I get 45 equals 4y. And when I do 45 divided by 4, I get 11.25. You could also say that was 11 1/4. You could say it was 45 over 4. All of those are acceptable answers for that one. So just be ready. Not everything divides out perfectly, so you can't just do everything in your head. You might have to actually work it out. I do want to show you one more thing on your practice. So if you flip over here to question 18 to 20. So this one and 18, 19, and 20 all go with the same picture, so you may want to redraw the picture for each one. So we've got this angle bisector here. HE is 10. This is not the one I wanted to do. Let me do number 19. So you've already got a picture for number 18. Number 19. HE is 8, HA is 12, and EA is 10. But I want to know EW and WA. So this one's a little bit tricky. They gave us the whole thing, and we need to divide it in pieces. So what we're going to do is we're going to call one part of this X. Let's say from E to W is X. Well, the whole thing is 10, so what expression could I write for WA? Don't say y, because I don't want to introduce a new variable. I'm just going to use what I have here. If EW is X, I'm going to call AW 10 minus X. And then I can set up my proportion. 12 to 10 minus X equals 8 to X. And I'll solve it that way. So just be aware, if they give you that entire side, you've got to split it into X and then the whole thing minus X in order to solve it. So be ready for that. Be ready for some fractions. Improper fractions are fine. Mixed numbers are fine. Crazy long decimals we don't like, so just leave them as fractions.